0.3 kg and m kg respectively. The particles are attached to the end of light inextensible string. The string passes over a small smooth pulley which is fixed at the top of a fixed rough plane. The plane is inclined, the horizontal at the angle alpha, where tangent alpha equals to 3/4. The coefficient of friction between P and the plane is half. The string lies in a vertical plane through a line of greater slope of an inclined plane. The particle P is held at rest on the inclined plane, and the particle Q hangs freely below the pulley with the string taut, as shown by figure 2. The system is released from rest and Q accelerates vertically downward at 1.4 meter per second square. When the particles have been moving for 0.5 seconds, the string breaks. Assuming P does not reach the pulley, find the further time that elapses until P comes to instantaneous rest. Okay, remember the moment the particle breaks, that string breaks, okay, there's no tension. Okay, always remember that the moment string breaks, there's no tension. Okay, so now let's solve this. First of all, okay, at P we have T. At P we have T minus mg sine theta minus mu r equal to ma. Okay, tangent alpha is given as 3/4, so sine alpha equals to 3/5, cos alpha equals to 4/5. Okay, and A is given as 1.14 meter per second square. Okay, 1.14. Now what's happening at P? Okay, at P, T minus, so I'm going to plug in all the information we have. T minus T minus, so mg, which is 0.3 times 10 times sine theta. Sine theta is, or sine alpha, which is 3/5. Okay, 3/5 minus mu is 0.5, which is half. Okay, so it's given over here, half. So 1/2 times r, which is mg cos theta. Okay, so 0.3 times 10 times cos theta, which is, or cos alpha, which is 4/5, and this is equal to 0.3 times ma, which is 0.3 times by 1.4. Okay, so when you solve this, you get T minus 1.8 minus 1.2 equals to 0.42. Okay, so from there we can get T equals to 3.42. At Q, okay, what's happening at Q? At Q we have m kg times 10 minus m kg times 1.4. This is equal to T. Okay, so what's happening at at Q is mg minus ma, and this is equal to T. Okay, or mg minus T equals to ma, so I wrote it differently. So from here, m kg is, I can put it in bracket, 10 minus 1.4, and this is equal to 3.42. okay, 3.42. So from there we get m equals to 0.3977 kg. Okay, now when the string breaks, what's going to happen when the string breaks? When the string breaks, okay, when the string breaks, string slacks, so no tension is present. Okay, so T minus mg sine alpha minus mu mg cos alpha, or mu r. Okay, it's mu r, but I wrote it as mu mg cos alpha, and this is equal to ma. Okay, remember mu r is mg cos alpha. Okay, so from there we get 0 because there's no tension, minus 0.3 times 10 times 0.6 times mu, which is, sorry, minus mu. Is there an eraser? I'll just go back. Yeah, minus. So this is, okay. Yeah, minus mu, which is 0.5 times 0.3 times 10 times 0.8, and this is equal to 0.3 times A. What is this A? This A is deceleration. Remember, this is deceleration. Okay, deceleration. Why am I finding the deceleration? Okay, because what happened the moment Q, the string snaps. Okay, P will come to instantaneous rest. It will move to a certain distance. After that, it will come to rest. So from there we know, okay, 0 minus, so this is 1.8 minus 1.2 equals to 0.3a. So a equals to 3 minus 3 divided by 0.3, which is negative 10 meter per second square. Okay, so this is deceleration, certainly. Okay, so now okay, I need some space. Okay, I'm going to continue here. Okay, I'll write it here. So before we find how long it took the particle to stop, we have to find the velocity it was traveling. So let's see what information that we already have. So we don't have S, okay, but we have U. We want to find V. I have A, I have T. So T is 0.5. So let's sub that. So I can take V equals to U plus AT. So V equals to 0 plus A, which is 1.4. Okay, before it breaks, what the speed that it was traveling. So times by 0.5. Okay, so from there we can find V equals to 0.7 meter per second. So this is the speed that it was traveling. Okay, traveling. Okay, traveling velocity. Okay, before it snapped. Okay, now after string breaks, it's traveled and stopped instantaneously. So we have to find the time. Okay, how long it's going to take. So the time is given over here, 0.5, and how long it was traveling. What is the, how long means what is the second, how long that it traveled after it broke. Okay, so from there we can use V equals to U plus AT again. So use this time U, V equals to 0. Why V equals to 0? Because it's stopping, instantaneous rest. And U is the same U as what we got here, the traveling speed. So U for the second stage is the V from the first stage. So 0.7, it was traveling at that speed, and times by A, which is -10, and times by T. Okay, so from there we can get 10T equals to 0.7, so T equals to 0.07 second. So the particle traveled and stopped after 0.7 second after when the string snaps.